Today is June 11th, 2022. It is day 328 of data science, and today I was kind of watching and revisiting day 93, like one of the videos I made in day 93, and it was basically on linear regression. And so I kind of wanted to review the topic, especially because I have a final in stats this Thursday, and yeah, I might as well just go and go back and review the topic. And so I just kind of pulled up day 93, and I'm just going to take the data set and I'm just going to do something really simple today. I'm not going to go like a whole hour and do like everything, but I'm just going to paste that data set that I got from day 93. I'm pretty sure it was like a doc that I had. Alright, so I'll import pandas before running that. But yeah, this is basically the data that I'm working with today. So it's just a bunch of toss numbers and a number of dice remaining after that toss number. So this is what the data looks like. So I'm going to use Seaborn, which is a graphing library full of pre-written graphing functions. And I'm going to import it as SNS, and then I'm going to do Seaborn scatter plot, and then I'm going to plot those values. So I'll plot the X values, which is a toss number, and then I'll plot the Y values just so we can get a look at what the data looks like. And so this is what it looks like. Okay, now I want to figure out, so I want to plot the regression line. So what is a regression line? So ideally the regression line is a least square regression line. So it takes the least, well, no, that's too complicated to say. In simple terms, it's a line, well, the equation of the line you can use to predict other values. And so in this case, I can use the equation of the line, of the regression line, to predict the number of dice remaining given a certain toss number. So yes, right now we have like the data, we know that if I have a toss number 1, that I'm going to have 14 dice remaining. If I have toss number 5, I'm going to have 2 dice remaining. But what if I want to know how many dice remaining I'm going to have at the toss number 9, right? And I can use a linear regression or a least square regression line in order to predict, like the equation of the least square regression line, in order to predict that the number of dice remaining when given 9 as a toss number. But there is a little caveat. Sometimes that line is not the best fit, and so you have to use that's what the video kind of went over. Like, this ended up not being the best fit, and so I had to go and look at other models to see which one would be the best fit. But I'm just gonna plot today. I'm just gonna plot the line just so you can kind of see what it is. Yeah, it's gonna be the same thing. So I'll just plot the values. It's just the scatter plot, but with the line drawn on top of it. Whoops. So let me just paste that in there. And then it should be the same thing. Oops, I spelled it wrong. Reg plot, now regular plot. So it's the same thing in the scatter plot, right? Except that you now have a line, and that is your least square regression line. And then you can use, hold on, let me do import SciPy as C. Let me run that. So SciPy is just a very data library. It's not like, how do I say it? It's more like, it's kind of like it's a very machine learning, deep learning type of library, you know? So one second, I forgot the function that I used. Or maybe it's Lin Reg. Let me see, Lin space, no. I forgot what the function is. It outputs the actual equation of the line. Oh, stats.linregress. See, I knew it was something about Lin. Wait, but from SciPy import stats. Oh, let me do this then. So can I just do stats.linregress? And then, do I put in my data frame or do I put in the values? I don't know what that is. Import from SciPy import stats. There we go. So I just wanted to make sure I only put the value in, right? She put, what the heck? Did I just call myself she? Well, I am a she. You know what? She put, as if I'm watching somebody else's video. I put, both, I guess it's the same thing, right? Because there's an attribute, not an attribute, a parameter. I think that it's going to be called data. Hold on. X, Y, Lin Regress. Okay, well, just in case, let me copy this. I mean, it should be the same thing. Right, let me run it. Yeah, it's the same thing. Okay, so we have two options. You could either put in each column, or you can just do data frame, as long as you have, you know, two columns, right? And it'll give you the same thing. So what this does, so from SciPy import stats. So stats is a function that has multiple methods. So SciPy is a library. So from the library SciPy, import stats. So we're importing a function from the library. So a library in Python is basically a place where you just have pre-written functions. So you can think of, like, in real life, you know, a library has books, right? So in this case, in Python, a library has pre-written functions. So it just has functions that are pre-written for you, so you don't have to write them over. So you can just use them. So then you can also use the methods that come with those functions. So in this case, I'm using the function stats, and I'm using the Lin Regress method. And then what this does, or I guess function also, I guess this is some function. I don't know the terminology, honestly. I know the terminology, but maybe not the best terminology. So this function or method, is it a method? I think it's a method. It is a method. All right. Lin Regressor Method basically takes your two values, right, your x and y, or your two columns, and then just gives you the line, like the equation for this line. And so that's what I was talking about. This is the equation, so that if you put in, right, a certain x value, it will predict a certain y value. So in this case, I know that a least square regression line is y, or y hat, or the predicted y is equal to a plus bx, or is it, yeah, so it's a actually is your y-intercept plus your slope times x, and so that is what the equation looks like. And so if we were to plug in these values, we have a slope of -1, whatever that is, and the intercept is whatever this is. And so I'll just do that, and then I'll do plus, and then I'll do my x value here, and this is going to be equal to my predicted y. And you know what I'll do? I'll just round it to 4 decimal places. So I'll just delete all these numbers until, so it's 4 decimal places, round like that. And so this ends up being my equation for that line there. And so the goal is now that anytime, let's say now I can just plug in 9 into here, and it would actually give me, let me kind of modify this. Okay, there we go. If I were to plug in 9, let's say I want to know the number of dice remaining in the ninth, what was it called? The ninth toss number, then it's going to give me, hold on, let me actually output it. It's going to say, well, you're going to have -3. Does that make sense? What did I do wrong? Number of dice remaining plus negative times -1 is a slope, right? Because it's going downwards. Oh, yeah, that makes sense. You're right. Oh, that does make sense, right? Because after 8, you can't. Okay, that makes sense. So how about toss number? Let's say, how many toss numbers do we have? Do we have 1, 2, 3? Well, we could do 0, I guess. That makes sense, right? 12.2857. So that makes sense. Because after 9, you would have like no toss number remaining because you did them all, right? But I guess 0 makes sense. You have like 12, plus 6 plus 6, 12 number of dice, yeah. Anyway, yeah, but this is not the actual best thing to do. Like in this case, it's not the actual, how do I say it? It's not the best fit. Like this line is not the best fit to predict values, because if you look at the residual plot, actually let's do that. Resid plot. Do I do ds again, or do I have to put in the two values? Ugh, why do I have to put in the two values? Alright, if you look at the residual plot, you can see that there's a curved pattern, and the rules of a residual plot, which is what I go over here, is that there can't be a curved pattern, and the data points have to be centered around 0, and clearly they're not centered around 0. Most of them are here at the bottom, and there's a curved pattern, and therefore this linear regression line is not the best fit to predict future values or any values at all, so, or like to predict the number of dice tossed. And so because of that, that goes into a whole other journey in which I just kind of finish off over here, and I try other models to see which one is the best fit, and I go through that and blah blah blah. So but yeah, this is kind of like going over the essence of it. And so maybe tomorrow I'll go back and try to find a data set in which, you know, the simple linear regression line just does it for you and actually is the best fit, so that you can see a better example. But yeah. Yeah. Okay, anyway, that's it for today. Bye.